Now, normally when you do the uncertainty for the mean, the uncertainty is normally just exactly what the uncertainty is for the individual measurements. And so the uncertainty for this mass of the beaker would be 20.01 plus or minus 0.01. Unfortunately, though, the uncertainty of the instrument is often not the main cause or the main issue of random error in your experiment, and you'll have like huge jumps. So perhaps maybe with the mass, someone's walking back and forth, or the air conditioner is blowing on the balance, and so the balance, there's force and pressure on there, so it's jumping up and down quite a bit. And so you can see here that even though the instrument should have an uncertainty of plus or minus 0.1 grams, you can see it jumps all the way from 0.5 to 0.04, sorry, to 0.2, which is the jump here of 0.16, and there's a value in between there as well. So what do you do when the random error or the uncertainty is greater than what it should be? And so that's 0.16 divided by 2, and that gives us a 0.08. And so for this one, you take whatever is larger. If there is the instrument error and it's not larger than that, you take that here as your uncertainty for the mean. But if there is a huge other random error, then you have to use this, and it's going to have to be, so instead of being 30.13 plus or minus 0.01, it's going to have to be 30.13 plus or minus 0.08. Okay, so there are two ways to do the uncertainty of the mean, and it'll probably be this one because it's probably going to be larger than your instrument error.